So if I have a set of infinitely, a set of all sets, then will it contain itself or not? If so it does contain, then I think it will not be a set, and if that's not, then it will still not be a set. My question is, I think the set will not even be a set. If it is like that, can you prove it or show me?
Yeah, please. We can get the question. Please come here. Yeah. Last question. কোনো হয়েছে কি কোনোদিন? গান হয়েছে, বাজনা হয়েছে, ড্যান্স হয়েছে, কিন্তু এই ধরনের সেশন কখনো হয়েছে? বোতল পড়ে বলুন হয়েছে? So big round of applause to those students, those who have participated in this question and answer session. Yeah, please. Only question in the book. Yeah. Please.
Oh, this is this is that question. Okay. Okay, so if a set S is a set of all sets, will it contain itself or not? So, of course, if it's a set of all sets, it will already have infinitely many infinite sets. It's going to contain all the natural numbers, all the integers, all of the real numbers, even the rational numbers, and even all of the sets that specifically have certain numbers not included in them, etc. So these are just some of the infinite sets that it will contain, and it will contain infinitely many infinite sets layered on top of one another, including subsets of itself, which means it would be perfectly reasonable if S could contain itself. But then again, here's why I think this is going to make it a little bit too funky. Why? Because here's the thing. Let's say, wait, never mind. Okay, so S is the set of every single set, which will include itself, and itself without a certain element, and itself without a certain few elements. So it will contain infinitely many copies of itself, and these copies have infinitely many copies of itself layered on top of themselves too. And I think that's perfectly reasonable. But, of course, it's questionable if a set can contain other sets. If it contains other sets, I would say it's not a set anymore at that point, because that can create quite a few paradoxes. So, like for example, let's say we have a finite set A that contains itself as well as one other number. Then what's the length of this set? So, I find the very concept of this being called a set questionable, since it contains other sets, but I think it's perfectly reasonable that it might contain infinitely many copies of itself. So this is true, but I think, no, it's not a set.
Sir, if it contains infinite copies of itself, then who will contain this set? If this does not contain this set, if the set contains infinite copies of itself, then who will contain the whole set S? And if the set does not contain the whole set S, then it will not be a set of all sets.
But the problem is, this is the largest possible set. There is no missing element, because every possible missing element is going to be contained in one of the sets that S has inside itself. But the problem is, this probably isn't a set because it contains other sets inside itself. But there are no missing sets because it contains the natural numbers without any specific element, the integers without any specific element, the real numbers without any specific element, and so much more, as well as the complex numbers and everything else. So there's literally no set which can contain S. Because that set itself is going to be a subset of X. It's going to be inside X. Something can't be both a subset and a superset at once, unless it's the set itself. So S is the largest possible set, meaning there's nothing containing it. But the problem is in itself inside calling it a set, because you can't have a set that contains other sets within it.
I think I will correct you somewhere which a set can contain other sets. Like in let's set we have like A of I which contains
Okay.
Like A of I, a set can contain other sets. Like if I have a set index set AI which contains of other index sets A1, A2, A3, etc. So a set can contain itself, but
Yes, but this is what we call a collection of sets, not a set in itself. So it's kind of a different object because regular sets contain regular numbers, but sets containing other sets, like this set, contains no numbers. So, does it even have a subset? Because if so, the only subsets are only sets that contain other sets. So, I mean, does this contain a number or not? Does it only contain sets? So it's better to just call this a collection of sets, because it itself is not a set of any numbers. It's, well, a collection of sets of individual numbers.
you want to say that the set is not a set but a collection.
Yes, this is the largest collection of sets.
Sir, can you prove it that this is a collection and not a set?
Proof?
Yes, sir.
Well, it's simply defined that a collection is just some amount of sets. Like, for example, we might use the definition of an open cover in real analysis as a collection of open sets. So why can't this be a set? Why can't collections be sets in themselves? Well, because A, their only subsets are going to be other collections, and B, what happens if a set contains itself? Like, for example, let's say this a collection or a set A contains the set itself and, I don't know, 1. So then, what's the length of this set? Is it... What the heck? Is it going to be 2? No, because it contains A inside itself, which itself has 2 elements. So what does that mean? Is it going to be 3? No, because A itself contains some elements. Is it going to be 4? So really, we can't say a set can contain other sets, because then what's the cardinality of the set? And also,
it is 2 sets because under the set there are 2 elements, so it is 2 sets. There's nothing else.
But 1 isn't a set, it's a number. Even though you can technically make 1 a set, that doesn't, that just worsens the problem.
Sir, if 1 is not a set, then it will not fall under A. Because if it falls under A, then it will not satisfy the definition of A, which is that it is a collection of sets with a set of sets.
I don't think we can define sets containing only a single element as actual sets, because then they're just elements on their own.
I have proved this in a way. Would you say me it is correct or not?
Okay, let's see.
The definition of sets is that it is a generalized collection of things. But this does not fit the definition, I think so, because it is not a generalized collection of sets. It is not defined actually correctly. What is a all set? Would it be a generalized collection or not? Sir, is my opinion correct or not?
Well, what do you mean by generalized?
Means that is for all, it is the same. It is not different for anyone or anybody around the world.
We probably memorize the definition.
Oh my goodness. Don't have to use ad hominem. But I think that this follows the definition perfectly fine, because I mean by your definition that single elements or sets, the real numbers itself are an infinite collection of other sets. Like even the natural numbers themselves are a collection of infinite sets. So, I think that in the same way, it's not wrong to have something like this, where it's got infinite versions of itself inside, which themselves have infinite versions of it inside. But of course, that's only if you choose to call this a set and not a collection. If you call it a collection, all of these logistical problems are removed, and a set is simply just a generalized collection of elements, not a generalized collection of sets.
Thank you, sir.
Of course.